Hi, this is your math coach, Howie Tutman, presenting What Math Should My First Grader Know? I've recorded videos in the four domains or groupings of standards in math for first grade. This video is the 10th of 10 videos in the Operations and Algebraic Thinking grouping. The video is about understanding the meaning of the equal sign. If you have any questions or comments, please email me at hrtutman@gmail.com. The complete text of the standard that this video is based upon follows at the end of the video. This is the first of a couple of standards in which the first graders work with addition and subtraction equations. In this standard, we want the first graders to understand the meaning of the equal sign and to know if equations are true or false. So what does this symbol really mean? This is our equal sign, and many first graders think that whatever comes after the equal sign is the answer to the problem that is on the other side of the equation. And where 5 plus 1 does equal 6, and in this particular equation, 6 is the answer to 5 plus 1, the right side does not always just represent the answer to what's on the left side. So let's take a look at a couple of different equations. In first grade, equations that students will be looking at would be adding, which would be a plus sign, with it joining two quantities together, or a subtraction sign, where they're breaking apart or subtracting one number from the other. So on this page here, I have all different types of addition equations. And in some cases, the operation will be on the left-hand side. This is 5 plus 1 is equal to 6. And this is true. And we would want our first graders to be able to either explain this, or if they need to use something concrete, they could use counters or Unifix cubes, or they might be able to just use drawings, which would be, say, drawings of counters or Unifix cubes or 10 frames. So for instance, here, 5 plus 1, we're showing 5 red counters, 1 yellow counter. So that's a total of 6 on the left side. And on the right side, we have 6 red counters. So what we're showing is that the value on the left side is the same as the value on the right side. In other words, they are equal to, they are the same as, it is the same value. And that's what we want students to understand. This next equation here, 6 is equal to 5 plus 1, this is also a true equation. The value on the left side is 6. The value on the right side, 5 plus 1, is also equal to 6. This is also a true equation. In this case here, we're showing the operation on the right side of the equation. Looking at another equation, we have 5 plus 1 is equal to 1 plus 5. In this case here, we're showing the addition operation on the left side of the equation, and we're also showing the addition operation on the right side of the equation. 5 plus 1 is equal to 6. 1 plus 5 is equal to 6. So this also is a true equation. And what we've shown here, and we've talked about this before, is the commutative property of addition. In other words, we can switch these add-ins around, and we still end up with the same value. Another type of equation where we have different numbers, this also is a true equation. On the left side, we have 5 plus 1, which is equal to 6. And on the right side, we have 4 plus 2 is equal to 6. They balance out. It's the same value on both sides of the equation. The left side, the value is 6, and the right side, the value is 6. Here's another type of equation. 6 is equal to 6. As long as there's an equal sign, we have an equation. There is no operation on either the left side or the right side, but this still makes an equation, and this is a true equation. The value of 6 is equal to the value of 6. And finally, on the bottom here, I have another equation. 5 plus 1 is equal to 6 plus 2. But is it a true equation? Well, the value on the left, 5 plus 1 is equal to 6. The value on the right, 6 plus 2 is equal to 8. Is 6 equal to 8? Do they both represent the same value? They don't. So even though this is an equation, this would be a false equation. Now, many first graders might look at this equation and think of it as being a true equation. What they're going to be doing is they're going to say 5 plus 1 is equal to 6. And if they're only thinking that the answer to the problem on the left side is whatever immediately follows the equal sign on the right side, they're only going to be seeing the 5 plus 1 on the left side, which they would know is 6. They see 6 immediately following the equal sign, and then they would be saying that this is a true equation. So we want to make sure that students perform whatever operation might be on both sides and then compare the value of the left side versus the value of the right side to then determine if the equation is true or false. Continuing on with the standard, we'll now look at some subtraction problems. So for starters, we have 9 minus 3 equals 6, or 9 minus 3 is equal to 6. And we'd want our first graders to know, is this a true equation? So if the students say yes, we'd want them to be able to show us or tell us why. So once again, some students might have to pull out some counters or blocks and physically or on paper be drawing, showing 9 counters, and they're going to subtract 3. So if we take 3 of our counters out of the 10 frame, we no longer have them. We're left with 6 counters on the left side, and we have 6 counters on the right side. So this first grader has shown us that they know that 9 minus 3 is equal to 6, and that that is a true equation. Other students might be able to just explain and say 9 minus 3, I know from my subtraction that that equals 6, and 6 equals 6. Therefore, I know that it's a true equation. Some other equations here, once again, to make sure that our students aren't thinking of the right side as just the answer to the operation that's on the left side. We'd want to make sure that our student is exposed to equations similar to this one. 6 is equal to 9 minus 3, and to go through the same process to figure out if this is true or false. And this would be true because 6 is equal to 9 minus 3, which is 6. Another equation we can look at is 9 minus 3 is equal to 7 minus 1. This is an equation that has operations on both the left and right side, and we'd want our students to go through and figure out the value of the left side. 9 minus 3 has a value of 6. 7 minus 1 has a value of 6. So the values or the amounts are equal on both sides. So that also is a true equation. So for the next equation, we have 9 minus 3 is equal to 6 minus 1. Well, we know 9 minus 3 on the left side is equal to 6. 6 minus 1 is equal to 5. So we would want our first graders to be able to tell us that this is a false equation and to show or tell us why. Now, once again, many first graders may consider this a true equation because they're looking at the 9 minus 3, knowing that that's 6, and they're only looking at this 6 right after the equal sign where it says 6, and they're not looking at the entire amount on the right side. So if your first grader says that this is a true equation, they need to be reviewing the operations that are on both sides of the equation and come up with the total value on the left side of the equation and the total value on the right side of the equation. Now, once you feel your first grader is really understanding the subtraction equations and that they had a grasp on the addition equations, you might want to mix it up a little bit. So here where we've been showing just subtraction equations, put in an addition equation and see if your first grader knows if this is a true or false equation. Because if they were just looking at subtraction equations and they quickly look at this, 6 is equal to 7 plus 1, they may think that this is saying 6 is equal to 7 minus 1 and say that this is true. So this you can stick in here just if you're trying to test to make sure that your student really has that grasp of knowing the addition and subtraction operations and that they would know that 6 is not equal to 7 plus 1. Therefore, it is false, and they can give you an explanation as to how they know that. And finally, we have an equation here of 6 is equal to 7. There's no operations on either side, but this is still a number sentence or an equation. I know some of the first graders were referring to equations as number sentences when they first start. So a number sentence or an equation is what we're looking at here. And the value of 6 is not equal to the value of 7, and therefore it is a false equation. And what you could do is you could ask your first grader, what can I do to either the left or the right side to make this true? And you may hear answers like, well, on the left side, I could make this 6 plus 1 is equal to 7. Or on the right side, they may make this 7 minus 1. So that would be equal to 6 plus 6. So that would be just if you want to further test your first graders to their knowledge of equations to see how they can turn false equations into true equations. If you're interested, here is the complete standard that this video, Understanding the Meaning of the Equal Sign, is based upon. Understand the meaning of the equal sign and determine if equations involving addition and subtraction are true or false. For example, which of the following equations are true and which are false? 6 is equal to 6. 7 is equal to 8 minus 1. 5 plus 2 is equal to 2 plus 5. 4 plus 1 is equal to 5 plus 2.